All right. Hello, everybody. I'm Matthias. I also go by the name Matsu on Twitter and GitHub. I think that's the most common name you see me by online. And I'm making this video just to showcase how you can utilize the Web Component DevTools to your use cases and how you can make the most out of using the Web Component DevTools. First, you can get the Web Component DevTools from the Chrome store. I will be leaving a link in the description, but you should find it on the Chrome web store with the name Web Component DevTools. And as you have it installed, you can use it on almost any Web Component custom element project, and it should work to an extent. There's some frameworks or libraries that are supported more than others, but I'm expanding the catalog by the day. And also there's some extra functionality you can gain by utilizing a new schema called Custom Element Manifest, which was developed by the Web Component community and is being adopted right now by a lot of tooling. So to get started, we're going to be first looking at just a regular vanilla HTML web component project. So the code is just a simple HTML element web component with a changeable title, a clicker, and a click count. So if we click, we can see the count increase, and if we change the title, then we can easily see the title update. So when developing web components, you usually want to see what's going on inside the component, what's the attribute states of the web component attributes, and what's the state of the properties inside the web component. And that's a use case that the normal DevTools can't really fill. So when you're in normal DevTools, you can see the attributes of the element, but you have no information about the properties of it. I mean, you could just copy the JavaScript path, hope it actually works, and then check the count property of that element. But that's going to be quite cumbersome when you have a lot of elements, and if you have something like shadow DOM and iframes, it's going to get messy in no time. So enter Web Component DevTools. So as soon as you have installed the browser extension, you are able to find a tab in your DevTools called Web Component DevTools. And by clicking it, you can see similar to the elements list, you will see a list of web components on your current page. For my page, it's only the my element right now. And if I click on it, I will see all the attributes of our web component listed here. And if we update the count, we can see the attributes updating in real time. It goes both ways. So if we update the attribute here, it also updates into the element and to the DOM. We can also update other string-based attributes here. And if we were to say add a Boolean attribute, we could also change that using the checkbox next to it. So we could toggle Boolean attributes with a simple click of a checkbox instead of having to use set attributes on JavaScript side. But if you want to get the so-called real experience of the DevTools, you are going to want to add a tool called Custom Element Manifest Analyzer to your project. That can be installed easily running the npm install command with the de prefix. So it's a dev dependency. You don't want to pack it with your project. And it can be found from Custom Elements Manifest /analyzer. I have it already installed, so I'm not going to install it. But if we start the project, it's going to be the same project we saw just now. And I can prove it by going here and showing you that it's the same exact project. But now the only difference is we have custom element manifest generation on runtime. So we have concurrently running two things at the same time. The first thing is the web dev server, which just fetches and serves our content. And the second one is the custom element manifest analyzer, which is running in watch mode. So every time we modify files, it runs again. And it generates a custom elements.json file, which has information about our custom element. And what does it give us in return? Well, if we open the Web Component DevTools again, we have the same listing here. But now, as you might see, we have a lot more information. If we didn't have the custom element manifest, the only thing we can reliably have is the attributes, because you can get the attributes from the observed attributes of an element. But with the custom element manifest analyzer, we can have so much more information because it's able to statically analyze the actual JavaScript file and not just a DOM object. And as you can see here, we have a couple of more properties listed here. We have the counter element and title element, which are here. And you might see a small mask next to them. It's a indicator that the elements are private. And all you need to do to create a so-called private element in JavaScript, there's no actual private in JavaScript because it's not a feature of the language, but you can mark elements as private with JSDoc. So you can just mark the properties when you declare them and give them the private JSDoc tag, and they will become private instantly. So you could use these to indicate that you shouldn't maybe touch these properties, even if you see them in the DevTools. We also see the connected property here, which we didn't see in the previous version. But on top of that, we see the normal properties and attributes that we saw earlier. And we can easily see that the attributes get reflected to the properties and vice versa. If we add to the count, we can see the attribute increase also. And if we add to the attribute, we can see the property react to it also. So it's when developing vanilla DevTools, vanilla components, it's really cumbersome to actually test if all the reflections from attributes to properties and properties to attributes work. And with the DevTools, it's really easy because you can instantly see from here if it gets reflected. You don't have to do anything else but look at this view. There's also a couple other categories that are gained from the CEM, Custom Element Manifest. The first one is events. And if you have any events firing in your component, so in my code, I have a this.dispatch event, my new custom event counter increments. So I'm launching an event every time the counter gets updated. With the custom element manifest, we can see the event listed here. And every time it gets triggered, it splashes with a green color indicating us that the event has been triggered. So it really eases you on seeing when events are getting triggered and are they getting triggered at the right time. And the fourth and final section we get from the CEM is methods. We have a list of all the methods we have in our custom element, which aren't part of the HTML element or aren't static methods or a constructor. So we have listed increment, which is seen here, set counter, which is seen here, and update, which is seen here. And if we call the increment function by pressing the button, we can see that it functions the same way as we would have when the button is pressed. That's because it basically just calls the function without parameters. Parameterless functions are marked with the green call function button at the start. If, however, the function has parameters, it will have a set params button next to it and a small summary button here. And if you press it, you will see the list of the parameters that the function call needs. And we could enter here any parameters, for example 25, and then call the function. And we see that it calls the function with the parameter we gave it. And it even is able to type the call correctly, because we have built our system so that it can type them correctly. Going forwards, this is the basic developer experience enhancement you get with the Web Component DevTools on vanilla elements. And I mean, you can easily work with just the version without the custom element manifest we saw here, which has the attributes, because when you're doing basic HTML element, custom elements, just having control over the attributes usually is enough. But if you need more control from the DevTools, I highly recommend you to install the analyzer in your project. It's a really small dependency and it's a dev dependency, so it shouldn't be affecting any deployment performance. It's just a great tool to increase developer experience and increase efficiency on developer side. But moving on, I've also built compatibility with some popular web component libraries, for example lit. The current compatibility layers I built are for lit, fast elements, and Atomico, which is a hook-based web component library. And if we start up the lit project here, it's just the normal OpenWC starter with some spice added into it. We can see the project. We can see the project here. We can see that the project doesn't have any other dependencies than lit HTML and lit element. And if we look at the actual web component, we can see there's just styles, some properties, a constructor, increment, and render function. And if we inspect this in the DevTools, remember this is without the custom element manifest. We see our element here. We get a nice wrapper around the element, displaying it on the page. And we have more information here than we had with the vanilla elements. So this is the lit compatibility layer kicking in. So instead of having just the attributes, we also have the properties, because we are able to get them from the custom element declaration of our custom element. And here we can see that the title is set to Hey OWC World, as we can see here. And we can easily modify it if we wish to do that. We can also modify our counter. We can add to it, and we can see that since we are reflecting our counter value, it gets also updated into attributes. And this is where the power of the DevTools also shines, is that if you have a object bound to your custom element as a property, you will get access to the whole object, no matter how deep it is. Well, there's a threshold at 100 levels, but I don't think anybody is going to pack a 100 levels deep object into the web component. You can access any layer of your object, and you can modify them at will also. So if we wanted to change the name, we could easily just modify the name here. Even arrays, we have the array here, we see the list here. We can modify any value we want to modify, and it gets updated in real time. Now we also can modify any string-based values, and they get reflected if they are added to reflection in lit element. And now for the example with the custom element manifest. So we are again gaining a lot of bonus functionality from just adding a single dependency to our project and running the analysis with the dependency tool. So if we go on the page, we can see from the code base that it's the it's the let's see. Oops. Yeah, we can see that the web component is the exact same web component we had there. But if we look at the inspection window here, we again see a lot more information that we had earlier. We can see that we have the styles and properties that are lit elements way of handling styles and properties. We can see them marked as static on the DevTools. That is a good indicator for developers working on a web component and debugging them, because they immediately see that which values are static and which values are not static. And also we would be able to modify any value here at our will. And on top of that, the Web Component DevTools, with the help of the custom element analyzer, is able to parse JSDoc typing. So if we gave a element some kind of a type with JSDoc, the custom element analyzer and therefore the Web Component DevTools respect the typing. And that goes to union types as well. So union types are practically, you could use union types, for example, in the place of an enum, which is not a data structure you have in JavaScript. Well, not in the same way you have them in more strongly typed languages. But here we have created the status element, a status property, and we have only two viable values for the status property here. We have the waiting status and ready status. Those are the only viable statuses because we have handlers for those statuses only. So if any other status is given, it just doesn't work. But if we type them as a union type, as you can see here, we are able to easily toggle them from our DevTools. We have a neat drop-down menu with all the union type values, which we can change, and it immediately changes the value on the DOM and on the element. So that's pretty neat. On top of that, we also have the event and methods. Again, here they work the same way as in the vanilla example, but those are just a neat feature to have with basically any kind of a library or any web component, because you might have a method you want to call without having to call them from the dev console by just finding the element, and then you would have to again copy the value and then maybe call the increment function. Instead of just going through that, you can just call function and it's doing everything it would do as if you would call it from here. So that's pretty neat. This is a great developer experience update on anyone working with web components or working with Lit especially. There is a couple more libraries I said it supports. The first one is Atomico. I will just quickly show you how Atomico handles it. So our my Atomico component compatibility layer has the same compatibility as Lit element had. So we're able to get the properties of the element easily, and we can even modify the properties or object properties inside properties, and we can easily modify any value we want on the page, which makes debugging a lot easier. It makes creating content a lot easier, and it makes just general testing a lot easier on any kind of web components. And again, this is without any kind of custom element manifest. And the last one of our compatibility layers that we currently have, currently being 8th of July 2021, is fast elements. I don't have a local environment for fast elements set up, but I will just demo it on the fast design web page. If we go on the web page and we open the Web Component DevTools, we are able to see all the web components on this page. and if we scroll to the demo here, we can even find any web components on the page. If we have the Web Component DevTools open in our window, we can right click on any element on the page and click a new selection here called Inspect Web Component. And the listing will immediately scroll to that web component and select it from the list. And here we can see that we have the properties again listed, and we can easily toggle the properties as we want. And the properties react exactly how you would expect them to react if you use them yourself from the DOM manually. But this is a huge upgrade to anything that you want to develop, since you can test them right in the browser without writing any boilerplate code just to test the functionality. A nice showcase of how well the object property inspection works is on the Lion Web Component website. If we just resize a bit, we have the search bar here, which is a lit element web component, and we have the results list as one of the properties. So if we write a search term into the search field, we see immediately that the search property updates on at will, but also that the result list updated every time we press the key. And you can also see that we have a small preview of each of the objects, which makes it a lot easier to see which one of the objects you might want to manipulate. And going in, you can go as deep as you want, or as deep as it goes, and you can modify even the deeper values. So if you want to modify the title here, we could just modify it at will. Can do anything. We can modify it at will, and it will update onto the DOM as if the value was there all along. If you want to try out the Web Component DevTools, the link is down in the description. There's a link to the web store page and also the GitHub page. The web store version is the most up-to-date package I've created. It sometimes might be a bit late from the master because the Chrome review process might take a few days to pass. But if you want to have always the most recent version of the DevTools, you could also just clone the DevTools from the master, but I don't think that is recommended, because the master is something that can easily be broken. So I would recommend in enterprise use to just use the Chrome Web Store version of the DevTools, because that is always a tested version and it's a reviewed version, so it's also safer for the user. I will also leave a link to my Twitter down below, so you can message me, tweet at me, DM me if you have any questions or any suggestions. I'm also active in the Lit and Friends Slack channel, which will also be linked down in the description, and you can message me there if you have anything to say about the Web Component DevTools. I hope this was an informative deep dive into the DevTools and how it might help you in your development, and I hope to see a lot of you using the DevTools and giving feedback on the DevTools so that we can iterate and grow into an even better set of tooling. But for now, I will just say bye.